Okay, this is the last problem on the review sheet for test 3. It's in the solutions on Canvas, but I also wanted to walk through it because we got really rushed there at the end of class, and this is not a super quick one that we're just going to be able to rush through and get an answer for. So I want to make sure I had the solutions worked out for you completely and make sure everybody understands what's going on. So we've got the inequality tangent squared minus x less than 3 is equal to 0. Okay, so we've already got everything on one side, and we can see that we're less than 0, and we know that that means that we're looking for where this graph is below the x-axis. Okay, so that's what less than 0 means. We also know that that means that we have to find where it hits the x-axis. All right, so we have zeros when tangent squared x minus 3 equals 0. And we know that if we can get to something squared is equal to a number, we can take the square root. So if we move that 3 over, we'd have tangent squared x equals 3, and we can take the square root on both sides, and we can't forget that plus or minus. So we would get tangent x is equal to plus or minus the square root of 3. Okay, so we've got tangent x is equal to positive 3, square root of 3. And we've got tangent x is equal to negative square root of 3. All right, now these are actually values that you can read off of the unit circle. So you would have them it would be at the pi over 3 interval. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. But just to run through this, how you would do it if you have to use the calculator, you can either use the zeros function on your calculator, or you can use the tangent inverse function. So you would put this in as tangent inverse. Whoops. Tangent inverse square root of 3. And that would give you your theta value. So when you plug that into the calculator and you're in radians, you should get theta is equal to 1.05. Okay, so that's our first quadrant value. All right, now there's a couple different ways that you can do this, and one would be to use that as your reference angle to find all of the other values, because you're going to have plus or minus square root of 3. So that would be your first quadrant value, and you can use that to find second, third, and fourth, all your quadrant values. Or you can say, okay, tangent's positive first and third, and I would find the third quadrant by taking the first quadrant value and adding pi. So I do pi plus 105, and that's going to be equal to 4.19. Okay, and then you can also find the second and fourth quadrant values from that angle, or you could do tangent inverse again of negative square root of 3. Okay, because maybe these weren't the same values. They're not always. And you would get theta is equal to negative 0.105. Okay, now we know that we want second and fourth quadrant values, and that is a fourth quadrant value, but we need 0 to 2 pi is what the direction said. So we're going to have to convert this. So second quadrant, we would get pi minus 1.05 to get our second quadrant value, and that would give us 2.09. And then fourth quadrant, it is in the fourth quadrant, but we need it between 0 and 2 pi, so you can either think of it as getting the coterminal angle or the reference angle in the fourth quadrant. Either way, you would do 2 pi minus 1.05, and you would get 5.23. Okay, so those are our 4 zeros. Those are our 4 x-intercepts. Whoops, not that one. This one and this one. Those are our 4 x-intercepts on the graph. Now, the other place that a function, an inequality, can change from positive to negative is anywhere that it's undefined. So we also want to look at the asymptotes. For this one, it's actually pretty easy because it's just tangent. It's just tangent squared. So you've got to look back at any place where the original inequality is undefined. So we've got asymptotes for tangent, and that's just plus or minus square root, plus or minus pi over 2. Okay, that's where tangent has asymptotes. We don't have to worry about doing any shifting or anything because it's just tangent. So that's pretty straightforward. So we're going to take those 4 values and we're going to take plus or minus the square root of 2, pi over 2, and put that on the graph. Okay, so let's get a new page going here. All right, so when you put this into the calculator, let me rewrite all those values. So we've got theta is equal to 1.05, 2.09, 4.19, and 5.23. Okay, those are our zeros, and then our asymptotes are at negative. I put negative pi over 2 and pi over 2. We actually want pi over 2 and 3 pi over 2, because again, we want 0 to 2 pi. That's where our picture is going to come up. Okay, so when we graph this, make sure that you're in radians, make sure that you've got 0 to 2 pi. The picture on your calculator is going to look like this. Okay, so that's what the picture looks like, and we've got to make sense of this. So first of all, we can put in our asymptotes. Okay, so that's at pi over 2 and 3 pi over 2. All right, and then we would also put in all of our zeros. So the first one is 1.05. The second one is 2.09. Sorry, it's hard to write that small. The next one is 4.19. Oh, where am I going to fit that? Here we go, we'll go sideways. 4.19. And then this one is 5.23. Okay, so you want to go through and label all those points. And then we are looking for below the x-axis. So we want this piece right here, this piece right here, and this piece right here. Okay, those are the parts of the graph that are below the x-axis. So when we set up the intervals for this, we see that we're going from 0 to 1.05. The original problem was including. Okay, the original problem was including. So I'm going to include 0 and 1.05. Then my next interval goes from 2.09 to 4.19. 2.09 to 4.19. And then my last interval is going to go from 5.23 all the way to the end. And I'm not going to include 2 pi just because it's not included in the original question. It includes 0 but does not include 2 pi. So that's why that one's a round bracket. Okay, so there's our final solutions, taking into consideration the zeros and the asymptotes, and then looking at the final graph to get the final answer.